There are many mineral-rich areas around the world, including Australia, Brazil, the Democratic Republic of Congo, South Africa, and the United States. From coal and tin to copper and lithium, these resources are economically important, but come with hidden costs. Mining operations can leave behind contaminants that seep into the environment, impacting soil health, plant life, and ultimately, human health. When we examine samples from mining sites, we often find troubling evidence of environmental problems. Heavy metals such as arsenic, lead, and mercury, byproducts of mining processes, can find their way into the soil, affecting entire ecosystems. For plants, contaminated soil interferes with how they absorb nutrients, how they grow, and it allows toxins to accumulate in their tissues. Plant roots are the essential point of contact for heavy metal ions in the soil, and these toxic substances can make their way into the food chain. For wildlife, pollution through the water supply and consumption of plants or fish can lead to accumulation in the tissues and organs. Some species, like the river otter, are an important bioindicator species, giving us clues about the level of contamination in rivers and streams. Water samples are also essential for assessing pollution. These samples are tested for dissolved heavy metals and other pollutants that may originate from mining operations. Analyzing water samples helps track the movement of contaminants from the soil into aquatic systems, affecting both ecosystem health and human water sources. When contaminated plants or animals are used for food, the pollutants then enter the human food chain. Long-term exposure to heavy metals can lead to serious health issues, including neurological damage, kidney problems, and an increased risk of cancer. This link between environmental contamination and human health underscores the need for careful monitoring and remediation. Remediation, or cleanup, is an important part of reducing the negative effects of mining. One technique called phytoremediation uses plants to remove contaminants from the soil. One plant group, the Brassicaceae, are useful because they can accumulate certain metals and still be highly productive. Indian mustard is one example. Other species like white willow and sunflowers are also useful in removing heavy metals. Natural history collections can play a critical role in conservation and remediation efforts. Collections provide insights into how ecosystems can recover and help guide efforts to restore polluted environments. The legacy of mining has far-reaching impacts on the environment and human health. By understanding and addressing the fate of mining contaminants in soil and plant systems, from the past to the present, we can address pollution challenges more effectively and ensure that ecosystems remain vibrant and that the health of our communities is safeguarded.